And the way this thing works is, sorry, I've never done all this before.
Doing great.
Okay, this machine is pretty neat. It's a scanning electron microscope, so it rasters back and forth, and you can see your chip as if you're looking at it through a SEM. But the gray level of everything you're looking at corresponds to the voltage potential. So if things are at ground potential, they tend to be very light colored or kind of white. If they're at VDD potential, they tend to go towards black. So as your chip is running, and it runs underneath this top here comes off, and then you put a special shell on here with your chip. So your chip is upside down in the vacuum, and then the beam scans it like this. Anyway, what this thing is, it's an oscilloscope. So you can just take a little virtual probe on the sun application window onto a certain chip and look at and it will go into this action, and it will sort out between 5 and 6 electrons per data band, and it will, over time, average out and build up a waveform so you can actually see what's going on the chip without loading it at all. I mean, it loads it somewhat, but with so few electrons that unless it's a very high impedance analog circuit, the e-beam prober will have no effect on it at all. But it's really nice because you can look at things like memories, and you can look at bit lines, which are very analog in nature, and they don't really lend themselves to digital analysis. But you could see the slew rates on everything. You could look at the coincidence of clock signals on the chip. And so this tool was really important in fine-tuning the color because it allowed us to get in there and see everything. And I think most chips don't get that kind of attention because the design flow is all very deterministic. The tool should ensure that you should have timing closure so that when you fabricate it and then you test it on a dedicated tester, it's kind of known good at that point. But there still could be latent defects in there that the design system never anticipated. But this way we can bring them all out by actually seeing them and then in response tuning our silicon by maybe adding an inverter or 2 inverters somewhere to slow the signal down to bring 2 signals and the coincidence. But this is stuff we never anticipated getting into when we wanted to design a chip, right? But it kind of was born of necessity. I hope that wasn't too boring.
No.
We'll walk around a little more. Here's where a lot of our inventory lands. And what we've got in recent, a couple years ago, about a year and a half ago, we started a business in China, which we have some employees at, and we send a lot of our high volume, kind of low tech stuff over there, and we get product back from China for maybe completely built and tested and packaged for maybe 60% what the raw material would cost in the U.S. So even if you look for free here, you'd be relatively losing money. It's kind of a sad state of affairs that in order to sell things cheaply, like the propeller proto boards, I think we sell it for $19. We couldn't really profitably do that here in the U.S. Now here, this is where we keep our finished goods. And then UPS and DHL and who not will stop by here a couple times a day and drop things off. This is Rob and Cody. These are students at UPS in Orlando.
Can you still see us on your screen, Chip?
I can see you.
Okay.
Yeah.
We lose our video of us every once in a while. So that's all right.
Oh, okay.
We don't
Though, your video hasn't updated in a long time. Why don't you guys wave your hands or something?
All right. Oh, yeah.
Yeah, see, your video's still.
Well, I hate to touch anything. Test.
Okay.
Yeah, we just want to see you, so that's good that we're frozen.
Okay. This is a cage that we keep all of our chips in. in a little cage like this, there could be maybe like $1 million worth of chips. We'll keep all of the FX propeller chips in here.
Hey, Chip, one of the guys is asking if you heard his remix of the 7.
Oh, yeah. Yeah, that was me.
He's got another one we're going to post.
Okay, great.
On the forum.
Yeah, I like that. That was neat. Now, in here, this is where we build a lot of our 8-amp modules and anything that's kind of, you know, surface mount intensive or low volume, we'll do here at Parallax. So this guy right here, what's your name? Sean? Travis? Travis here, he's putting legs on stamp module. And so when we build the stamps, we build them from a monolithic circuit board. Thanks, Travis. Thank you. Awesome. This is Russ here. He's been gone for a few months, but he's back today. Students at UC University, Florida. Okay. Can you see this? Okay. This is how we build our basic stamp. We start off with the monolithic PCB, and we use a pick and place to place all the parts. And here's our pick and place. This is an Infineon machine with 8 heads, so it's real fast. So this puts all the parts onto the circuit board. And after that, it feeds it over here into this oven, which is on right now. You can see the conveyor moving. And then the boards come out down here and land on the top of the box. And then we pick them up and we wash them after that. And then over here, we saw them up. So this is a special lapidary saw that we had built. We used to use a little kind of Dremel tool, an air-driven Dremel tool, but it didn't do a good job and it's real noisy, so we had this thing built for it. So we have this special place that our board connects onto it, and then each little board is captured by 2 tooling pins. And so you run them through the top. Okay, so these are all done, huh? Okay, this is... Yeah, this is Natalia. He works out here. These are some students in Florida.
Oh, wow. Hello, guys. Hi, Doug.
Yeah. So she's sawing those things up. Are you guys still there?
Yeah, we're still here.
Okay. And then here Travis is putting the legs on. So after they get sawed up, they look like this. And with this little machine here, it kind of aligns the lead frame with the module. And then when it gets squeezed together, everything's in registration. There, all crimped together. And you tear off these little sacrificial pieces. And then